All right, next up, as you've already guessed, is our speaker Vitalik, who's actually going to be talking about upgrading infrastructure for rollup-centric Ethereum. So whenever you're ready, V, feel free to kick it off.
Great, thank you. I'm going to, I guess, share the screen, and then I'll use the magic trick that you taught me to only share a portion of the screen. And then, okay, there we go. Do you see it okay?
Yep.
Okay,
Perfect.
human beings. Okay, so great. So today, what I will talk about is basically thinking about this concept of a rollup-centric Ethereum, something which is was a vision 1 year ago and is, I think, on the cusp of becoming a reality, or even is beginning to become a reality today, and kind of think through some of the kind of side issues, various pieces of infrastructure that we sometimes don't think about in order to make a roll-up-centric Ethereum world something that actually is a pleasant environment for people to live in. So just to kind of recap a bit, the concept of roll-up-centric Ethereum was started to be introduced around the end of last year. I guess this post literally from October 2020, so 12 months ago. This came from an observation that basically showed that, like, if you look at our current roadmap, any way that we could realistically do the roadmap, we have a proof of stake first, then data sharding, and then only after that possibly other kinds of sharding. And so in the Ethereum base layer roadmap, there's only room for a relatively small amount of scalability, like with Virtual trees, maybe 2x or 3x, but can't really go far beyond that, right? And the problem is that we need much more scalability. Like even today, we I think need at least a 10x, and in the long term, we need 100 to 1,000x. So what would the only technology that is available and that was actually making a huge amount of progress even back then is rollups for the layer 2 scaling solution. So this was a kind of brainstorm of, well, given that rollups are Ethereum's best hope, what would a roadmap that's designed around that fact actually look like? And again, the answer basically is, well, we have a lot of technology that we can already do to make rollups work and to make rollups work better. So we have obviously rollups themselves. A lot of work being done on fraud proving, a lot of work now being done on the ZK EVM to make EVM capable ZK rollups possible. Some work being done on wallets. The projects themselves have been making huge progress over the last year. And sharding itself, right? The first step of sharding is data sharding, and data sharding by itself is enough to increase the amount of data space available to these rollups by a factor of close to 100. So there's basically a lot of things are already happening to make rollup-centric Ethereum actually be a reality. And today rollups are kind of here, right? So there is our optimism. You can do things on optimism. There is Arbitrum. You can do things on Arbitrum. There's Loopring and ZK Sync. You can make payments on Loopring and ZK Sync. There's Polygon, which is not a rollup, and it's a trusted sidechain at present, but they bought Hermes, and they seem to be on a track that will get them to being a ZK rollup at some point in the future. Rollups are kind of underway, and you can use some of them, but it's not quite there yet, right? Like the scalability of a lot of them is far from optimal. So, like for example, when I wrote my blog post on rollups, one of the things that I talked about was how to get the really big scalability gains. You have to do a bunch of compression work and to get the transaction size down to 16 bytes. And Optimism and Arbitrum yet have not done this. But they're on their way to doing it. There's but until then, right, while transactions still take more than 100 bytes, fees are not quite as low as they can be. Loopring and ZK Sync are at that level already, right? So their fees are, sometimes like 20, sometimes 40 times lower than Ethereum itself. And once these rollups do add proper compression and they do add better signature schemes, then they'll be able to get down to these low levels as well. So Scalability, it's still a work in progress. EVM rollups still have training wheels, so they still have centralized backdoors, just because the fraud provers are either not quite finished or they're still in beta, and people are not quite comfortable fully entrusting things to them yet. So it's it's sort of come kind of on the way, but we're getting there, right? Like the rollup-centric Ethereum is not just a vision now; it's something where there's a very clear path to it, and people are already starting to use projects that are either rollups or that are kind of well on their way to becoming rollups. So far, rollup-centric Ethereum is, I would say, just still a success. Obviously a work in progress, but everything is a work in progress. So even the merge is a work in progress, but we've had a successful test that 2 weeks ago. So it's happening. But there are still things that are missing to make a rollup-centric Ethereum actually easy to use, right? You can talk about rollups being available in theory, and then you can talk about, well, rollup-centric Ethereum actually being in a blockchain environment that you as a user would want to live in. So what is the gap between those two things? First, kind of motivating question, right? Why can't I use a loop ring to pay for coffee, right? Like, we want what blockchains, we want our big application of them is cryptocurrencies, and we want cryptocurrencies to actually be useful as currencies, right? And what's the point of a currency if you can't use it to also pay for the small things, right? So obviously you can't use the base layer to pay for coffee because the base layer is expensive, and the base layer is meant for big and important things like layer 2 commitments. But we have layer 2s, and we have loop ring, and loop ring is already quite efficient. And loop ring does payments. So why can't you use a loop ring to pay for coffee today, right? Like, why? I think there's a lot of reasons for this. Like, one is just that there hasn't really been a serious effort toward making it happen. But I think another big part of the answer is that loop ring today is kind of like a bit of an island, right? Like, if you're within loop ring, you're within loop ring. If you're not within loop ring, then like it's kind of hard to move funds to being within loop ring, right? Like, you have to do a layer 1 transaction. Layer 1 transactions are expensive. Then on top of that, you have to wait. So the UX of getting into loop ring if you're outside of loop ring is not very good. And if you're inside of loop ring, there's not that much that you can do inside of loop ring, right? Like, you can exchange, you can trade, you can have tokens. There might be an NFT feature, but like, you can't have your fancy DeFi stuff. Like, you can't have fancy NFT auctions. You can't make a CDP and then borrow some coins from that CDP and then stick those coins into another magic DeFi thing. There's a lot of fun stuff that you can do in a full EVM environment that you just cannot do in Loopring because Loopring doesn't yet support that functionality, right? So there's basically 2 ways of solving this. One way of solving this is for Loopring itself to turn into a ZK EVM rollup, and that's technology which is in progress. But another part of another possible solution is to make it easy to get into Loopring if you're not yet in Loopring. So cross-rollup bridges, right? This is the sort of thing that I've been thinking about for a while, that other people have been thinking about for a while. So here on the left, I have this post on ETH Research where I give some ideas for how you could make NFT wrappers where the NFT could be issued in one rollup, and then the NFT could be moved to another rollup, and you can have NFTs jump between rollups, and you don't need main chain transactions for this. There's a project called Hop, which is trying to make a trustless or scalable bridge to go between one rollup and another rollup. I had another post on ETH Research that tries to do a rollup to rollup bridge that only requires one side of the bridge to actually be EVM capable. So you'd be able to have a decentralized bridge between, say, Optimism and Loopring. So cross-rollup bridges are important. And I think we want cross-rollup bridges to be trustless. So to have trustless safety and trustless liveness, to be infrastructure that we can count on to just exist. But this is still something that is in progress, right? So the more work can happen on cross-rollup bridges, the more we can make it very easy to move between any one of these Ethereum layer 2 domains to any other Ethereum layer 2 domain, the better. But this is something on which there has been some work, right? There are already some like limited cases where you can hop from one rollup to another. but it's still something that needs to be worked on a bit more. So cross-rollup bridges is one problem that needs some work. Other problems. So let's take ENS. ENS, probably the single most popular or most successful non-financial Ethereum application, right? And it's a use case where it actually makes sense to use a blockchain for it. So lots of people have ETH names. I have a .eth name, Vitalik.eth. Lots of other people listening to this probably have a .eth name. Status, the Ethereum chat application. Status users have use.eth names as usernames inside of Status. Blogs can have .eth names. So if you go to Vitalik.eth and try to access it as a website, then you can find a copy of my blog. So lots of different applications of ENS, and ENS seems to be doing great, right? But there's a problem, which is that it takes more than $10 to update an ENS record, right? So if you want to buy an ENS name, if you want to update a record, if you want to do anything through ENS, then you need to pay more than $10, right? So for example, if I want to update the ENS record for Vitalik.eth, the blog, to update the IPFS content hash, then that's something that I have to pay more than $10, and so it basically costs me I forget some number of dollars, somewhere between 10 and 30, I forget, every time I want to update my blog, if I want to keep it updated with ENS. So can layer 2 fix this, right? And the answer is it should, right? Layer 2 should be able to fix this, and we should be able to move ENS over to layer 2 in order to make it so that these record updates, instead of costing $10, they can go down to costing $2 today, 25 cents tomorrow, and 2 cents 2 years from now once sharding is stabilized. But we need to have a standard for how to resolve ENS domains stored inside of layer 2s, right? So there's 2 ways of doing this. One way of doing this is to say, we're just going to socially coordinate ENS as a whole, moving over to one particular rollup, right? So we might say, oh, ENS, we're going to choose Arbitrum, right? And ENS is going to live inside of Arbitrum, and ENS will just work the same way it works today, but instead of talking to the Ethereum blockchain, they'll talk to the Arbitrum rollup. So I think this is not a great solution. And the reason why it's not a great solution is that, first of all, it creates a long-term dependency on one specific rollup. And so far, we're not yet sure which particular rollups will prosper, which particular rollups we will actually want to use. And second, people might have other reasons why they want to live inside of some other rollup. And so it would be nice if EVM can live where they live, right? People are not necessarily going to have an account on every rollup. If one particular person just likes Optimism and they want to live inside Optimism, then, they should be able to have their ENS domain inside of Optimism. So what would be nice is to have some kind of cross-rollup standard, right? So ENS should stay rooted in the Ethereum chain, but there should be a standard where if from the point of view of the Ethereum chain, you move an ENS domain over to a rollup contract, then you would be able to manipulate and do things to that ENS domain inside of the rollup. So good news is that there's this protocol called Buterin, ERC3668, Secure Off-Chain Data Retrieval, which is trying to serve a bunch of use cases, but where this is one of the use cases, right? So basically the idea of Buterin is that you would be able to set your ENS record to be set to an address where that address defines an off-chain record keeping system. And that off-chain record keeping system, it would basically have a smart contract where it would point you to a place where someone trying to get the data would be able to grab the basically state inside of either the Optimism rollup or the Arbitrum rollup or whatever rollup you choose. They'd be able to grab the state that shows what is the current state of that particular record. And then the contract would also have a Merkle prover. And so you would be able to fetch a Merkle proof and verify the Merkle proof. And you would basically still be able to actually get what the current state of that record is automatically, right? So basically from a client point of view, the client's point of view would be step one, it would think that you have an ENS record on Ethereum, and so it would call the ENS contract. It would try to access your record on the Ethereum base layer. Then it would realize that your record is stored in this particular contract, which is an off-chain data retrieval contract. It would call it. The contract would return a off-chain data lookup error. Then that error would contain instructions about where you would go and get the Merkle proof. Like could be a list of URLs, and it could be a huge number of URLs, so you have a lot of redundancy. And then you, as a user, would just try pinging all these locations, and you would ask for the light client proof, and then of the state associated with that record, you would get that light client proof. And then, so that's step 2. And then step 3 is that you would locally do an ETH call, and you would call a proof verifying function on that same contract. And that proof verifying contract would verify the proof. And it would also tell you, like, basically what is the state that just got verified. So that would actually tell you that, like, hey, that function was actually supposed to return like some particular value. Now, in order to update the state, or this internal state, like, you would not have to send Ethereum transactions, right? Because these are all state updates that would happen inside of a rollup, and the only things that would happen on chain is that Merkle roots of the rollup state would continuously be getting updated on chain, right? So on chain, you will just be Merkle roots that get updated, and then all of the actual operations that happen inside of the rollup would be happening off chain. So this is a nice solution, right? Because it allows you to basically extend your kind of ENS infrastructure so that it automatically can go and fetch this kind of the state of your ENS records inside of a rollup. So if I have Vitalik.eth, I could move Vitalik.eth into a rollup, and then if I want to make any record updates, I could do those inside of a rollup. Or potentially, if you want to handle the use case of people registering new subdomains, then like someone could make an entire subdomain, move it inside of a rollup, and then all domains that are subdomains of that domain could then be registered, and everything could be done with them inside of a rollup, right? So like for someone like Status, if they want to make it possible for people to register new names at the cost of a few cents instead of $10, then like they could register a subdomain and move that subdomain to inside of a rollup, or they could even have different subdomains inside of different rollups, and users would be able to register a new domain, and that new domain would be a subdomain of that domain, but they would be able to do the entire process purely inside of a rollup. And the infrastructure that actually like gets ENS record data client side would just be able to do all of that. It will be able to fetch the data from the right rollup automatically, right? So you would not client side software would not even need to update to be able to handle new rollups. So new rollups would just be able to add themselves into the system automatically. Very versatile, so it can work with optimistic rollups, it can work with ZK rollups, it can even work with Polygon for now. So that's definitely something that I am very excited about, and hopefully with this sort of thing, we can finally have an ENS world where ENS domains are cheap to register again. Light clients. So this is a third piece of infrastructure that we're making a lot of progress on today, right? So in the world of just Ethereum, after the Altair fork, we're going to have this concept of sync committees, right? A sync committee is basically this committee. It gets committed to inside of the beacon chain block headers, and then that committee is going to basically sign messages attesting to a block header. And then that block header can be a signature can be verified against that block header and against the sync committee. And so this provides this very cheap algorithm where a client will be able to keep up with the beacon chain at a very low cost, right? At a minimum cost of something like 40 kilobytes a day, plus like maybe 500 to 1,000 bytes for every single header that they want to verify, plus Merkle proofs. So with Altair, you're going to have these sync committee inside the beacon chain, and with the merge, the beacon chain and the execution chain are going to merge. And so you're finally going to have a path where you're going to have these SIG committees that will actually verify like Ethereum blocks, and we're going to be able to have trustless light clients, right? So today, wallets like Infura and like basically every or wallets like MetaMask and every wallet that exists today either talks to Infura or they talk to some centralized system. In this light client world, instead of talking to a single server, they could talk to end servers, right? So they could have a collection of end servers that they talk to for redundancy. They could receive and they could validate Merkle proofs from each one. And whichever one is online, they could get proofs from it, and they'd be able to validate Merkle proofs locally, right? So you would not have to trust the servers to be honest, and because you would have n of them instead of one, you would not have to trust them for liveness, right? For liveness, you would just have a one event trust assumption. So there's a big opportunity here with the merge and with the light clients to finally move away from this kind of centralized Infura world and move toward a world where we actually do everything much more trustlessly with proof verification. But there's a question, right? Which is, does a move to layer 2 protocols risk reversing these gains? So this is a light client of Ethereum. But now, if we're going to be talking about a world where you don't just have Ethereum, but you also have people using Optimism, people using Arbitrum, people using Polygon, people using Loopring, and then next year people are going to create 3 more rollups. Like, how are light clients going to be able to handle that world, right? And this is the risk is that if we don't provide a good way for them to handle that world, then what's going to happen is that they're just like Infura is going to be the one that creates nodes for all of these systems, and they're just going to end up trusting Infura, right? So how can we move away from like centralized trust dystopia and make sure that these gains in decentralization actually apply not just to the base Ethereum chain, but also apply to layer 2s? So there's a good news, right? The good news is basically that we can use ideas very similar to Durin to create a generic layer 2 light client system, right? Basically, the idea is that systems like Optimism and Arbitrum and with these layer 2s, they could return a list of URLs, or they could return, basically return some kind of mechanism by which the clients can get proofs for a particular piece of state that they want to access, and they can provide a function for verifying proofs, right? So the function could be a Merkle proof verifier, could be a polynomial commitment verifier, could be whatever. And clients, they would first poke the layer 2 contract. The layer 2 contract would provide a list of locations where they can try to get proofs. It doesn't have to be like the URL standard is like very extensible, right? So eventually this could be an address of a peer-to-peer network as well, right? So they would provide a list of just kind of ways of getting proofs. The clients would get proofs. The L2 contracts would provide a function for verifying proofs, and then clients would verify these proofs automatically. And so any software which is a light client of Ethereum would then automatically be a light client of every L2 that supports this standard, right? So if you have any light client which supports Ethereum, then it would also be a light client of all of these L2 protocols. Now, this is amazing, right? And it's amazing because basically we'd be able to keep these really nice trustlessness properties, not just for Ethereum the way that it works today, but also for this kind of layer 2 expanded universe of Ethereum of the future that's going to have much higher scalability, much lower fees, and greater decentralization compared to today. So those are like 3 of the examples of very big and important situations where we need a layer 2, like we need other infrastructure in order to make layer 2 Ethereum a world which is as usable and as decentralized as we want it to be. There's also plenty of other examples today, right? So like wallets needs to be able to jump between layer 2s efficiently. We need to make sure that security for L2s works well. We need to make sure that exchanges on all of these systems work efficiently. We need to just to figure out, like, every individual DeFi platform needs to figure out, like, is it going to live inside of a single L2? Is it going to cross L2ify itself? So there's a lot of these pieces that need to be worked on. But the good news is that, like, in general, Layer 2 centric Ethereum is not just a vision. Layer 2 centric Ethereum is a reality which we are in the process of building today. Still a lot of rough edges, but these rough edges are continually being worked on, continually being improved as we speak. A lot of really impressive work happening on ZK EVMs, both the Hermes team and Barry's team doing a lot of good work. A lot of amazing work happening on off-fraud proofs for optimistic rollups. I saw like both Optimism and Arbitrum are doing some really amazing stuff. There's Optimism, and then there's George Hotz and all of his amazing work on Canon, and basically literally compiling Geth into an environment so where you can then compile it into a TrueBit-like system. Then there's Arbitrum, which is doing, I think recently had a blog post where they're taking a similar path. So a lot of really amazing work happening on layer 2s. Compression is something that I personally have kind of been pushing really hard, and I expect this is one of the things that's going to start happening pretty soon. So I expect we're going to just see continual decreases in transaction fees on Optimism and Arbitrum. But no, we have to make these rollups not just work well as individual rollups, but we have to make the layer 2 Ethereum as a system easy to use, right? It's not just a matter of scaling up from Ethereum being a city to Ethereum being a country. We also need high-speed trains between the cities, right? We need high-speed rail to go from one city to another city without having to everyone pass through downtown. So at the same time, though, these are things that we actually can do. The tools are there. We can build these things. There's a lot of opportunity for building these things. There's an Optimism retroactive public goods funding gadget, which may well retroactively fund you if you help to build these things. So there's a lot of opportunity. But there's also a lot of work to be done, right? I hope that people listening to this, and I hope that anyone can kind of be part of the solution and help kind of actually build out this world, so that we can actually have this amazing layer 2 Ethereum of the future. So thank you.
Thanks, Vitalik. That was awesome. Got a few things to dig into. We have lots of time, so we'll see if the next speaker joins in a little bit early. We can end up on too many things, but let's start kind of reverse. So you just talked about this interesting project Geoff is doing with the Optimism Go to MIPS. Can you just walk into tell us more about what that is, what's happening, and how does that work, and sort of let's kind of get some little bit of an overview on that, and then what do you think sort of your opinion is on that?
Sure. Yeah. So Canon is really fun, right? It's basically this EVM fraud prover. And the way that it works, right, is that instead of creating a new EVM implementation that's and then worrying about whether or not it's compatible with the existing ones, basically what it does is it takes like an existing Ethereum client, so in this case Geth, and it compiles Geth into, or it compiles like basically a version of Geth that is, I guess you can think of it as a stateless client. And then it compiles that, it takes a block and it takes proofs and it verifies that it's correct. It then compiles that into this architecture called MIPS, which is basically a very simple virtual machine. And then separately, there is a project which is basically building a TrueBit for that virtual machine, right? So basically a kind of interactive fraud prover. It'll take like 1 billion computational steps of this virtual machine to actually run. But then you would have this game where if someone challenges the results, they have to provide 100 intermediate values, and then the original creator will then decide like which of those intermediate values they disagree with, and then the challenger has to provide 100 intermediate values beside those intermediate values, and you kind of start narrowing down where the actual disagreement is, and then finally you just execute one step of MIPS on chain, and we figure out whether the challenger or the original prover is correct. So same technology as TrueBit, right? Except you just like apply this directly to this kind of like EVM verifier that you basically took by just directly compiling an Ethereum client into it. This mechanism is really nice because it's also very general, right? So it's very easy to update. So if Ethereum has a hard fork, very easy to update. Like you don't need, there's no separate implementation that needs to be updated. You just update existing implementations. You could even extend it to do things that are fancier. So like one idea that you could have if you want to be clever and you want to be really robust against like software bugs is you could do the same thing for Geth and Nethermind and Besu. And you have 3 fraud provers. And then you have a separate fraud proving process where if someone proves that a particular block is valid under one client but not valid under another client, then you raise an alarm. You know, for what happens to that roll up, you can delegate it to governance. But then like you raise an alarm, and I mean potentially like that's something like you could even create an automated bounty for, right? So like there's a lot of really fun things that you could do there.
I was going to say maybe just to get a little bit clarity on one of those things. So because of this proof-style arbitrary computation model, do you think this is an extension to rollup in this case, where you can now do more with rollups that we couldn't do before, or is this more of an adjacent thing?
I think it's like allowing us to do what we've known was possible all along, right? Like there's no one who ever, I think, ever doubted that you can make an EVM rollup. I think it's just like a whole bunch of details, right? And this is just a way of making those details happen much more quickly and easily.
Gotcha.
Yeah, because all you have to do is you have to just create a true bit for a very simple virtual machine, and then the rest is just compiling existing software into it, and then like, which is something that you have tool chains for as well.
Interesting. Okay, no, that makes sense. We're going to be slightly off topic on this one, but I know this whole thing was focused about rollup-centric world, but maybe it'll be good to contrast this with state channels. What do you kind of think about that? I can't go into specific, but let's say there's any high-level thoughts on that when I just had that question, and I have 2 specific questions around state channels that we can dig into.
Right. I mean, I think like what we've learned over the last few years is that state channels are a very specialized technology. They're amazingly good at a particular set of things, but users don't just want to do a particular set of things, right? Users just want like dumb EVMs. So I think there is this really big and important central place for dumb EVMs, but at the same time, state channels have really important roles. And like, I don't think it's state channels versus EVMs, EVM rollups. I think it's state channels and EVM rollups. I think state channels can form a big part of creating efficient bridges and decentralized exchanges between different rollups. State channels can still be useful for kind of like micropayments and the kind of multi-payments to individual parties. Rollup-centric Ethereum and sharded Ethereum and all of these more scalable Ethereums also imply moving toward a world where no single node is going to have all of the data to figure out what's going on locally. And so nodes are going to have to talk to other nodes. And like I talked today about how when a node talks to another node, when it receives responses, how it can use Merkle proofs to verify those responses. But what we haven't talked about yet is like how those nodes get compensated, right? And like you could consider a client node having a long-running relationship with a provider node, and that long-running relationship could be paid for with state channels. So that like that's just like a very simple way of paying for requests, right? Like I pay you for a bit, and then you send me an answer. I pay you a bit, and you send me an answer. And so like the amount by which either party can cheat the other is extremely low. So that's another example of a use case for state channels. So I think like between like clients and data provision and cross-rollup bridging, there's lots of stuff for state channels to do within the rollup verse.
That makes sense, and I think one thing we've seen in the past is that for state channels, wallet integration has sort of become challenging because the wallets have to manage the state. But given the success of what we've seen with the world of rollups, CK or Optimistic in the last year, we've also kind of seen in parallel state channel projects like Connects or Seller kind of pivot into multi-chain approaches where they connect with other outside chains. Is that still a possible future for an alternative to the rollup strategy, or do you think rollups?
I mean, my personal view is that rollups are just like better than sidechains, because rollups like they benefit from the full security of Ethereum, and like basically there's this kind of nice tight coupling property, right? Like where you can trust that the rollup state is kind of like an application on Ethereum can unconditionally trust that a rollup state is correct, right? Whereas if you have a bridge between two kind of chains that are both quote sovereign and they're separately sovereign, then like if one of those chains gets 51% attacked, then the bridge stops telling the truth, right? Or if the bridge gets attacked, then the bridge stops telling the truth. Whereas like a lot of the bridges, they do still rely on multi-sigs or whatever. Whereas with rollups, like the rollup bridges have 100% accuracy from the point of view of inside of the chain, right? Now, obviously, it's possible that there's a 51% attack on Ethereum and then Optimism gets reorged. But if that happens, then whatever thing you did that depends on Optimism is also going to get reorged, right? So you're actually 100% safe. So I think like those there is that really important kind of tight coupling property that you get from being inside of a common security layer, which the rollup Ethereum verse is. So I view that as being a benefit of doing rollups, but at the same time, there's going to be other applications that are very low value per transaction. And so it might not make sense to pay the fees even for rollups. And like, okay, fine, like those applications could still be in a sidechain in the short term, and then in the long term, like once ZK Starks are good enough, then everything should be either a ZK rollup or a Validium. So, yeah.
What do you think of, I guess, monolithic changes versus like multi-rollup futures, or just choices there?
I think realistically, multi-rollup is inevitable. And like, there's just, I mean, like first of all, there's just like already multiple rollups, and there's these different approaches. There's, I mean, even like if we assume that there's like trade-offs between ZK rollups and Validiums, and some people want to be one and some people want to be another, you're going to need bridges between them. And it just, a multi-rollup world, just like, it feels more scalable because you just naturally have much more parallelization, right? Like, different rollups use different shards, and the different rollups have different computers that are creating the proofs for them. So right now, like the multi-rollup world feels more likely. Obviously, it's definitely possible that I'm wrong here, and we do just get like one ZK rollup that ends up dominating the whole thing. But we'll see what happens.
Do you think Bitcoin could be a rollup one day?
Oh, fun. I mean, for Bitcoin to be a rollup of Ethereum, like the community is gonna have to accept proof of stake, which I guess.
Yeah, we don't have that sense.
Yeah. Well, we'll see.
So kind of coming back to the rollup-centric world, as you kind of just talked about, there's a lot of things where inevitably you can have anywhere from one rollup being more popular to just kind of having some specific features that are valued more from one, or valued or offered by one rollup than the other. What should change, or what changes for a developer when they're thinking about deploying an application? Like, obviously there's some trade-offs on compatibility or composability. Yes, you may have different parallel worlds, but it also, I think, in some point makes development not as easy. Would you agree with that, or kind of what does that?
Makes like, the question is like, what are the challenges for developers when moving their applications to rollup land?
Yes.
I think the main challenge is that an application has to decide whether it lives inside of one rollup or whether it's natively cross rollup. If it's a natively cross rollup, then like you have to actually think more about the infrastructure of like what being natively cross rollup actually looks like. And like, even if it lives inside of a rollup, then like there might be cases where people just like want to like kind of like bite off some portion of the activity of your application and like move it over and do it inside of another rollup, right? So you do have to kind of think about cross rollup nuances. But even if you don't, then if you don't, then I guess the challenge is that you lose composability with applications that live inside of other rollups, right? Like if you have Uniswap inside of Optimism and some DeFi thing inside of Arbitrum, then like you can't do synchronous operations between the Uniswap and that DeFi thing. But I think like realistically, there's going to be a copy of Uniswap with at least some liquidity inside of every domain. So like inside of every rollup, inside of every sidechain, and obviously on the base chain as well. But that's like basically how to kind of interact with the newly found kind of ability to move between domains is something that application developers need to think about. Like what's the thinking around DNS and the thinking around NFTs would be one example of that. Like how would, like, say, loot work if we assume that we want loot to be accessible to people that aren't willing to burn $40 on doing every operation? And what happens if, like, some loot is inside of Optimism and other loot is inside of Arbitrum? Like, how do you recognize loot that's in different rollups? I mean, very similar challenges to ENS, right? Well, for a good reason. Like, loot is an NFT and ENS is an NFT.
This area for more experimentation if you have no cost transacting. Yeah, that makes a lot of sense. Another question, which is I think indirectly related to one of your slides from the talk. Wallets are the first interaction and barrier to entry for an end user, and writing mnemonic key phrase every time won't scale for an average user or hard drives. So I'm just repeating. What do you think about the current state of wallets, and what solution do you think we should implement to make that smooth, especially with layer 2 in mind?
Sure. So I mean, for wallets and keys, like, as I've said many times, I'm a huge fan of like social recovery wallets, and I think social recovery wallets for your hot wallet, for like your assets that you need in it to be for everything you do that's convenience oriented, and multi-sig wallets for everything that's not convenience oriented. And I think the same wallet can manage both, right? So, but then in order for that to happen, we need account abstraction. And like recently, myself and the GSN people and Nethermind people have been collaborating on ERC 4337, which tries to make account abstraction work without any protocol changes by kind of doing this overlay using user operations. So very much encourage people to look into that as well. And like, that's something that I think people should very much be starting to hack around at this point. And I guess the good thing that's happening now, right, is that all of these rollups are moving toward being just EVMs. And so if you have one wallet, like, you should be able to take that wallet software and just deploy it on every domain. So, you know, if you can have like one wallet, probably same address on every domain, maybe, you just, like, you have the same wallet software that can actually manage your wallet, your kind of wallet and your funds inside of each one of them. Then I think that could be really convenient and really amazing. And then, like, basically, I think the fewer wallet applications that users need, the more effort they can put into a kind of the backup and key management for each one. And so the less the risk of unfortunate security accidents happening, and the better the experience for people.
No, that's absolutely fair. Do you think there are any other, well, actually, I think the answer is yes, but what are some, I guess, open problems for the world of rollups to still figure out in order to sort of achieve that goal? Are there still open questions or considerations?
I guess like the sequencers need to speak this account abstract, like they need to speak ERC 4337. If they do natively, that would be amazing. I think realistically, like I think rollups are a better experimentation ground than the mainnet because they're cheaper. So I could easily see account abstraction wallets taking off in layer 2s before they take off in layer 1.
Got it. Okay, so just still on kind of the sequencers managing account abstraction, right?
Yeah, like sequencers should, like, I think you know, the Optimism and Arbitrum sequencers should ideally just like speak ERC 4337 natively, and that should be like one of the priorities for them.
Well, I know a couple of L2 projects watching this, so hopefully we get to work on that soon. All right, well, I don't think I have any other questions. Vitalik, thank you so much for taking the time today.
Thank you too.
Awesome. All right, everybody, we are running a little bit ahead of schedule. So what we'll do is we'll take a quick 5-minute break, and then we'll do our last talk of the day, which is going to be an AMA with Miyaguchi from the Ethereum Foundation. So sit tight, enjoy the next 5 minutes as I break, and we'll be back.